Hello, everyone. My name is Rajiv Paladh from Bosch Capital, and thank you for joining the session today on sustainable sludge management strategies at water and wastewater treatment works. Joining me on the call is Jason Holder.
Thanks, Rajiv. Hi, I'm Jason Holder, Divisional Manager of Wastewater in KZN and responsible for the technical elements of this presentation.
In terms of the projects, Bosch Capital looked at the project from a sort of financial, commercial, and strategic viewpoint, and Bosch projects were responsible for the technical engineering components of the studies that we were involved in. So in terms of the overview of the presentation, we'll provide an overview of our understanding of the problem statement related to wastewater treatment work residues and sludges, present some of our findings from the projects that we've been involved in here in KZN as well as in the Eastern Cape, present the financial implications of a modeling exercise that was conducted on one of the projects, and discuss some of the recommendations and way forward. In terms of the presentation, we use the word sludge to reflect both wastewater treatment work sludges and residues, just for ease of communication. So we understand that sludge disposal from wastewater treatment works and water treatment works are a challenge for water service authorities around the country. This includes both the compliance on environmental compliance as well as sludge quality that is being produced. And Jason, can you take us through the other items on the slide related to the problem statement?
Sure, thanks, Rajiv. As you said, the most common sludge disposal method currently occurring at these sites is to landfill or to agricultural land, and even disposal on the treatment site itself. In terms of the legislation, it was promulgated in August 2019 that the solid content of sludge had to reach a minimum % before it could be disposed of at a landfill site, at a registered landfill site. Very, very difficult to achieve this without additional drying to the dewatering process. And I would say most of the treatment sites within South Africa are not adhering to this requirement. And in terms of the regulatory requirements of assessment and classification, there are key government national regulations, 634, 635, 636, and the SANS 10234, which talks to the classification of waste, its management regulations, the assessment of waste for landfill disposal, and there's also the guidelines for the utilization and disposal of waste, volumes 1 to 5, and that applies to both the waste water sludges and water residues.
That really highlights for me, Jason, the issue of understanding what the sludge is going to be used for, how the sludge is going to be disposed, and then aligning that with the regulatory requirements. In terms of the frequency of sludge assessment at labs?
Yes, and in terms of the Waste Act, upon the generation of the waste within 180 days, the waste generator has to classify the sludge, and this reclassification occurs every 5 years. If there's a change to the process, if there's a modification to the process, then the waste generator has to reclassify as well.
So it really is understanding when the sludge needs to be classified and what's triggered any changes with that. So what we found from the projects that we were involved with here in KZN as well as in the Eastern Cape was that not all the laboratories were SANAS accredited for all the suite of tests that were required during the classification process, and none of the laboratories that we contacted during the course of the study could undertake all the tests in-house. In fact, one of the requirements were needed to be completed in the United Kingdom. Jason, you want to talk us through the remainder of the findings on the slide?
Thanks, Rajiv. Quite correct. We were able to go through one laboratory who was able to actually submit these samples to other laboratories that could assist with certain tests. However, for the 2,4-D analysis, that had to be taken off-site out the country. And holistically, the cost of analyzing at these laboratories are very expensive. So it does indicate that there's a need for regular monitoring and sampling of sludge. And also in terms of the landfill sites, not all landfill sites are classed adequately in order to receive these hazardous substances. And we even found that some of the landfills that are classed adequately choose not to take or choose not to receive the sludges at their sites. And so what often happens is illegal storage and dumping of sludge occurs around the treatment sites.
So just to be clear, in terms of the storage of sludge on treatment sites, you need to ensure that you're aware of the sludge classification, and if you are able to store on site, as well as taking into account additional measures that might be required for on-site storage. So one of those could be the provision of a lined area for the storage of sludge, which may not currently be the case.
Correct.
So in terms of sustainable sludge disposal options, what we've got on screen now is the waste management hierarchy that gives guidance in terms of the disposal options in terms of sustainability. So you want to look at reducing the sludge. It's next to near impossible to achieve total waste avoidance. There'll always be a sludge that's going to be generated, but we need to consider how this can be reused. Also consider the reduce circular economy principles of reuse, recycle, and recovery. So when we speak about reuse, this is seen to be the most sustainable option in terms of application to suitable agricultural land, and that's in sludge as sludge currently exists without the addition of any other raw materials. We have the opportunity to recycle sludge as a raw material in the production of compost bricks or briquettes, so that's introducing an additional raw material to the sludge. Importantly, reuse and recycle options both require customers or an off-taker, unless the WSA is able to use the sludge on their own property or for their own use. Recovery of sludge is seen to harness the energy potential within the sludge, and this is by generating biogas, which could be used for electricity. Treatment and disposal is the last resort in terms of on-site treatment, as well as disposal to landfill. That's seen to be right at the bottom of the waste management hierarchy. Jason, any comments on the slide?
Yeah, just to reiterate that in terms of the avoidance and reduction, products and materials must be designed in a manner that minimizes their waste components, or in a manner that reduces the natural material quantities used and potential toxicity of waste generated during the production and after use. This is unfortunately unavoidable within the treatment of raw water and wastewater streams. This level highlights the need to consider dewatering of sludges in order to reduce the volume for disposal, and really promotes the consideration of circular economy. Thanks.
Thank you. So in terms of the financial modeling exercise that was conducted in one of the studies for a 24 megaliter day wastewater treatment worksite, is that we considered the different solutions that are available for sludge dewatering, drying, and ultimately the disposal at a landfill site that was 20. So in this case, the negative number on the left indicate the total cost to the municipality. There's no revenue stream here. Ultimately, all of these options are going to cost the municipality in terms of the capital operating expenditure associated with these. What we see is that the centrifuge, belt press, and the filter press cost much less over the total project life cycle, and that's because you've got capex associated with dewatering units, operating cost of dewatering units, and the transportation of that sludge. Importantly, though, the outputs from these unit operations are not compliant with the minimum solids content for sludge for landfill sites. Sludge drying beds, therefore, are seen to be a more compliant option. Importantly, the disposal cost in this case is driven by volume, distance to landfill, and disposal fee. And what we see, if those numbers changed significantly, then the outcome from this scenario could be very different. So in terms of the recommendations and way forward as we see it, you really have to evaluate your options against your current disposal methods, and consider both the financial and the non-financial aspects of these projects. Because whilst you might have a financial viability of storage on site, you need to ensure that you are environmentally compliant as well. So it's important to consider a holistic approach. And really, you need to get into the detail of a disposal strategy per water services authority. So you can't look at this only at a wastewater treatment work site, or you can't look at this at a global level. You have to get into the detail and work out the costing per WSA to ensure that a thorough study can be undertaken to understand what the risks and challenges are per water services authority. Further, if you are going to consider engaging a customer to accept the sludge, it's useful to identify and engage these customers upfront. This could be an agricultural user or manufacturer that uses the sludge within their processes. And really engaging with them upfront also gives you an idea of their appetite and what their requirements would be to enter into a long-term agreement to accept the sludge. Jason, you want to talk us through the last bit?
Thanks, Rajiv. Yeah, so further to the high-level beneficial and sustainable options that we've spoken about, there are key additional steps that requirements that will impact on the final disposal options need to be confirmed. Environmental requirements, triggers, licenses, etc. The required studies relating to all licenses are required. As you mentioned, understand the market, speak to the agricultural owners. There's also the industrial sector, and even the social impact, the appetite, the sort of social acceptance of these reuses, and even soil assessments. Detailed soils and underlying assessments are required to understand these sites. And I think this goes a long way to understanding the cost benefit going forward. Thanks, Rajiv.
Thank you for that, Jason. And thank you for everyone that's joined the session today. Please do not hesitate to contact us if you have any further questions. Thank you.